Alright guys, this is gonna be 3.3, 3.4 because Mr. Hong is not gonna be at school today. So let's get started. So 3.3, 3.4, we're gonna be talking about the same exact thing that we learned from 3.1 and 3.2, which is solving. But instead of equations, we're gonna be using inequalities. So what that really looks like is like these inequality signs instead of equal signs. So it's pretty much the same thing, but instead we're using these inequalities. So how we're going to do it graphically and algebraically. So we're going to be using a lot of Desmos, and that's okay. Okay, so solving by graphing. So what is the solution of the following systems? So if I use Desmos by graphing this, you can see oh, if I need to graph it like this, if I can find out how to. Okay, okay. X plus y equals less than 4, and 4x plus 3y is less than 18. So you can see that where it's shaded for both, where it's just like the purple in Desmos, is my solution. So solve each quality for y in terms of x. What that really means is like, well, I'll take the first one. So equation 1 is x plus y is less than 4, which that means is like I'm going to subtract x on both sides. So y is less than negative x plus 4. The second one, this was equation 1. Equation 2 is 4x plus 3y is less than 18. So I'm going to move the 4x over. So 3y is less than negative 4x plus 18. When I divide by 3, I have y is less than negative 4 over 3x plus 6. Good. So I'm going to graph this at the speed of light. So you can pause the video right now and we'll look at the graph together. Okay, so I came back and I graphed this correctly. But what happens is that I need to actually shade this correctly. So I'm going to shade yellow for the blue line. Mine is not going to be perfect because I'm using a computer, but you, when you're on your paper, you will be perfect. And the red line. So all of this orange area, that is my solution. So now we're not even looking for, just a intersection. Now we're looking for common shaded areas. So let's see. Graph the boundaries. Use a dotted line or dashed line. Ooh, that's bad. A dashed line for less than or greater than, and use a solid line for less than or equal to or greater than or equal to. So shade the appropriate boundaries. So we're going to be talking about shading up above or below. So what that means is like both of my equations, you see how y is less than blah 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 and y is less than blah blah blah. I already knew that, well, if I use the blue graph right here, for example, if I choose this point, I need to go directly downwards. So you see how I graphed everything downward or shaded everything below this blue line? It's because it's less, the y is less than. So if I take that same principle, like if I choose this red graph, I'm going to go downwards, I should shade that whole area. And so I use pink to shade the red area. And I used yellow to shade the the blue area. So the solution set is where the shaded regions overlap on the graph. So test the point by, well, making sure that our statement's true just by choosing a point. So I'm going to choose this. I'm going to choose a very easy point, which is going to be 0, 0. So if I use 0 plus 0, 0 plus 0 is less than 4. Well, that's true. And that means that my double shaded area is good for now. But I have to also plug in 0, 0. Like, remember we talked about our solution is an order pair. So it's going to be 4 times 0 plus 3 times 0 is less than 18. Well, that's also true. Because 18 is bigger than 0. Because 0 plus 0 is less than 18. That's true. So that's just how we prove it for now. This is like a very simple and easy equation right here. So what about this one? What is the solution of the following systems of equations, inequalities? Is 2 comma negative 5 a solution? Well, try it out. Try graphing this by yourself and see if it is a solution or not. So let me give you time to try that. In 3, 2, 1. Okay, so we're back. I didn't graph it on my paper, but you should have. But I'm going to also show you what it looks like on Desmos. So I'm going to decrease this. So this purple, like dark purple area is my solution because both the green and the purple is shaded in this triangle right here. So the more diagonal or southeast I go, the more solution I have. So the question is 2 comma negative 5 a solution? Well, let's see. You go all the way in. 2 comma negative 5 is like right here. Or even if, let's say for example, I want to know, I will do 2 comma negative 5. And it will label it for me. So is that in my dark purple triangle area? Well, yes, that's true. So I would say like 2 comma negative 5 is a solution. Good. Example 2. So write a solution to a set of inequalities. Find the maximum possible y value in the solution set of the following systems. So I would like for you to try to type this into Desmos and see what would go on. So we're gonna come back after I graph it on Desmos. So you should try this time by pausing the video and try graphing it on Desmos and see if it works out for you. And 5, 4, 3, 2, 1. Okay, so I graphed this again. So I graphed, well, y is less than or equal to 4x and y is less than or equal to 5 minus x. So I need to find a solution in here. So I can choose some random solution that's double shaded. So like this area. So I can even say like 0 comma, what is this? 0 comma 1? Yeah. So I can say 0 comma 1 is a solution. Just because it's in this double shaded area. So you should have graphed this on your graph. I'm going to draw mine very fast. It's going to be right here. 1, 2, 3, 4. 1. So 1, 1, 2, 3, 4. Like this. So this is a solid line. Like so. This one's going to also be a solid line. So it's going to be plus 5. 1, 2, 3, 4, 5. And it's going to look like this. Yeah. There we go. And I'm going to shade downwards for both of these. So I'll use this blue for the blue this time. Like this. I'll use blue for blue. Whatever, it doesn't have to be perfect. I'll use this red. I'll use this green for red. So it looks like this. I'm going to leave some white in here for fun. Ooh, the green actually just overshadows the blue. So let's try this. Ah, that's better. So you see how like the purple and the blue, or the pink and the blue creates this dark, creamy, like purplish color. Like it looks like really old cotton candy. This is our solution. So 0 comma 1. So looks like right here. Wait, hold on. Did I write that right? 0 comma negative 1. 0 comma negative 1 is a solution, which is like 0 comma negative 1 is like right here. I'll call it that green. This will be green. So this is right here. That is true. It's inside here. So it says to find the maximum possible y value of the solution set. So you see how it creates a triangle right here? I need to find the y value of where they're intersecting, because where they're intersecting, this is going to be my highest point. So y equals 4 is my maximum, I'm going to just write max, possible y value. And I use Desmos to find this because, well, my intersection is, well, this triangle is the top part, right? This is my intersection. There's nothing higher for y value on this triangle where it's both shaded, well, it's like a dark blue-green instead of just green or just blue. It is blue-green. Nice. So let's take a look at number 3. Yeah, number 3. Number 3 says, this is a word problem. So Maria babysits $4 an hour. She also works as a tutor for $7 an hour. Sweet. She is only allowed to work 13 hours per week, as you should as well as a part-time associate, as you are a student as well. She wants to make at least $65. So write up a system of equations or inequalities that represent the situation. So I told you guys in class that we have 2 equations, equation 1 and equation 2, and you should put themes for each equation. So for themes, I'm going to say money. And the second one, I'm going to be talking about hours. So let's talk about money first. Let's just say her babysitting job is X and tutoring is Y. So I'm going to color this accordingly. So I know that she makes $4 an hour per babysitting hour. So 4x plus, well, she makes $7 per tutoring hour. So I'm going to put 7y. And she wants to make at least $65. At least. So which one's going to be bigger? The amount of money that she makes or 65? And of course, the amount of money she's going to make, you want it more. So there's my first equation. My second equation is going to be talking about the hours themselves. So I already know that this is 13. She wants to work, she's only allowed to work 13 hours per week. So can she do 15 hours? No. So the 13 has to be where the inequality is facing. But can she work exactly 13 hours? Yes, she can. So the number of hours that she can work is consisting of babysitting and tutoring. So it should just be X plus Y. Nice. So the question says to write the system of inequalities that represent the situation. So honestly, I'm done here. The whole point of this question, like for example 3, was for you to just say, I can make an equation based off of the story. So this is my answer as so. If I wanted to solve this, which I will do because I'm a math teacher and I want to enable you, 4x plus 7y is greater than or equal to, ooh, wrong one, greater than or equal to 65. X plus y is less than or equal to 13. Here we go. So this triangle is what she is gonna do. Like this is where our solution lies in, this dark triangle. And let's see. That means optimally she could work like 8.6 hours at, or 8 and 2/3 of an hour, or I guess it's 8 and 40 minutes, 8 hours 40 minutes at her babysitting job, and 4 hours 20 minutes at her tutoring job for the most optimal position. That's right. Here we go. The last question before we end it. So it says a pizza parlor charges $1 for each vegetable topping and $2 for each meat topping. Oh my god. So I'm gonna just say vegetable is gonna be topping for X. I just love using X. And I use X and Y a lot for these equations. Is because Desmos does not like you using like different letters. So you should try using X and Y as much as possible. So meat, I'm gonna say Y. If you're vegetarian, I'm sorry. Just know that the $1 is associated with the vegetable topping and then $2 is associated with the meat topping. If you want to have at least 5 toppings on your pizza, you have to spend $10 on toppings. Oh god. This is going to be an expensive pizza. How many of each type of toppings can you get on your pizza? So I have to represent an equation first and I have to solve it because it's not asking me um, write a systems of inequalities to represent the situation. I asked you how many of each type of pizza, like topping, can you have? So you have to give me an answer for this question. Well, first I have to write my equations. Like if I don't have my equations, I can't write it in Desmos. So this is probably like one of the harder types of questions where you have to find and create your own equation. So remember, we're going to be talking about themes. So the first easiest theme is to talk about is money. And the second topic is toppings. So I'm going to write toppings. I misspelled it. Don't tell your English teachers. Here we go. So the money is that, well, if I have vegetables, well, if I put a $1 per vegetable topping plus $2 per meat topping, I need to use Y. That has to be, well, I want to spend $10 to, you have $10 to spend on toppings. So I have $10. I don't have to spend it all. So do I want the amount of money that I'm going to be owing greater or less than $10? Yeah, that's right. You want to make the 10 as big as possible. So if I have $10, I can spend $10. So I can also put this equal sign as well. So I want to have at least 5 toppings on my pizza. So I can have 5. I can't have 6. So if I have 5 toppings, I cannot have 6, but I can have 4. So my equation still needs to look the same way where I cannot do more than 5. 5 is the biggest I'll have. So vegetable topping is X and the meat topping is Y. So here we go. There's our 2 equations. Let's try it out. X plus 2y is less than or equal to 10. And x plus y is less than or equal to 5. So it looks like my answer is like double shaded right here, which is right here. So I can choose anything of here. So I can even do like 2 comma 2. This is part of my solution. So I can get this. So how many of each type of topping can you get on your pizza? Well, I can do any number, like as long as, like for example, I can do 5 and 0. Whoop. Okay, this is a good thing. I did not have a virus on my personal computer. I can do 5, 0. I can do like anything within this line right here, I'm allowed to do. So let's try to find some whole numbers. I can do 4, 1. Like remember, this is vegetable and this is meat. I can do 5, 0. I can do 0, 5 right here. I can do 2, 3. I could do 1, 4. All of these are possible solutions. So in the multiple choice question like of this kind of esque, it will be like, okay, here are some examples of like some answers. Which one's not true? That would be expected of you to know. So that concludes like the lesson for today, which is about 20 minutes. Let's talk about the homework. So this definitely does not look like your homework because I made it super short compared to what it is now right now. So I would like for you to finish this practice, 3.3, 3.4 practice, and have it ready by the time I come back. So I'll see you on, well, Thursday. Make sure to finish your due now and your exit ticket before you leave class today. And I'll see you guys next time. Bye-bye.